Good morning, good afternoon, good evening, wherever you are in the world, guys. Welcome to another Alistair C123 welding video. Yes, you guys have been holding out for a while, and finally we've got one heck of a project to show you guys. We have another monstrous 18-ton swing jaw out of a static plant jaw crusher. And the swing jaw is broken completely in half. So yeah, one single casting, definitely over 10 tons in weight, broken in half. So they brought it to me to weld it back together again, and I'm not gonna lie, this was an absolutely daunting project. So yeah, I'm gonna start off this video with a quick visit to the last one that was done, just to see how it's going after a couple of years work. At the time of repair, you know, you just never know how long these things are going to last. So a couple of years later we'll check in with the last one I done, and if you want to check out the video of that, go through my playlists. I've segregated all my different video genres into different playlists, and there's a welding and engineering playlist there for you guys that love that sort of stuff. And you'll be able to see the repair of that swing jaw. It was a ludicrous welding project. There was 20 rolls of wire into it. So yeah, check that out, and we'll go and take a quick look at how that's doing, and then we'll get stuck right into the repair of this other swing jaw that has arrived with me. And man oh man, how do I get these jobs? Brutal, absolutely brutal, but makes good viewing. So stand by for some mega welding and gouging and all the rest of it. You know the drill. That is a monster, absolute monster. So as far as I know, this is a Kleeman Reiner MC125, and from what I can find online, it weighs 130 ton, and it will crush in the region of 650 to 700 tons of rock per hour. So if you imagine this thing's running for 12 hours a day, it's crushing 700 tons of rock an hour. How much stress and strain the actual crusher itself goes through, and over enough time it eventually breaks, and that's when I get a job. So this is the actual swing jaw that I welded together. I'll put a link in the description below to the video of the repair process, putting this back together with 20 rolls of wire. And this is very similar to the one that's on its way to be repaired, except the one that's coming to me is cast steel, a much trickier process to repair. So yeah, we'll go to the quarry where we'll see it on the floor, broken in half. Ready for the splash? So we'll have a closer look. This is the bottom half of the swing jaw. The rest of it is still in the house, attached to the main body, shaft and flywheels. I'll put another link to an animation showing you how these machines operate and what they look like, so you can understand what you're looking at. As I say, that's the bottom half, completely snapped, clean break. This is the top half, still in the crusher house. You can see the webs where they broke, and myself for some scale. Each half, I reckon, is about 5 ton weight. So there we have it, folks. It has arrived. What a mess. Oh, definitely got another mission starting. Oh man, yep. I'm getting the full intimidation right now. Unreal. She's a big girl. Yeah, she's a big girl. 18 tons in that section alone. I think there's about 6 ton in this piece. Man, oh man, oh man. Why did I take these things on? I'm shaking in my boots. So the first part of this mammoth job is stripping both of these large flywheels off. The main body bearing housings, and then the inner bearings and the shaft itself. We have to remove the wear part from the tail piece, and then both sections will be going to shop blasters for a thorough clean and blasting of the weld area. It's the quickest, best, most efficient clean. It'll give us good preparation to start with. So we'll set a wee time lapse up. Some mega labour to get these things apart. That is what you call a persuader. That's a 28 pounder, and that's what it takes to get the nut off the flywheel. 28 pounds of muscle. I'm out of breath because I just loosened that one. So yeah, both wheels off. Hopefully it won't be too tight. That's the answer. We've got the nuts off the bolts that hold the wear part on the bottom side, so we'll lift it off. We've got Sammy here doing the work. I've known Sammy for 30 years. I was his apprentice in the quarries when I was 13-14 years of age. I absolutely love this guy to bits. He's well into his 60s now and he's still working like an absolute machine. One of the hardest working people I ever knew. Honest, salt of the earth person. One of the best, Sammy. Yeah. Job's a good one. Throw in the dumper. So next we'll take the toggle seat out of the bottom of the broken piece. This toggle seat is the main pivot that the whole cam action pivots on to crush the rock. After that, we'll take the splash plate off the very top of the jaw that Sammy's doing at the moment. Below the splash plate are the main wear part wedge blocks. After that's all removed, then the work begins to take the flywheels off. The flywheels are off, that gives access to the body bearings and the shaft inside. Thing. So that's a good old shot. I'll put her on YouTube. Put her on YouTube. Are you gonna be famous? There you go. There you go. You have her. That is what you call a wheel nut. So it is. Serious, boy. Serious. But I do it for the love of it, for the interest in it, you know. Yeah. You know. So the key as well, it just stays and you pull the flywheel off the key. Wee shim. Packer, but the look of it. Oh, the locker, right. Wonder how many tons she is. Yeah, 80 maybe? Maybe even less, Sam, being hollow. I know there's big solid ones somewhere. Yeah. That's the flywheel removed off the tapered shaft. Next will be the main body bearing housing and bearings. Behind this covers a massive bearing. A lot of work to get us stripped down. So speeded this up a little bit, and I've had to cancel the sound because unfortunately there's music playing in the background and I get completely demonetized. But basically the flywheel has been loosened and it's hanging on the crane. I think the flywheel is in the region of about 3.5 tons, and we're wiggling it off the shaft. You can see the massive pillar that was used to break it free off the taper. Pillar is just a very large hydraulic jack, and it's operated by a 10,000 psi power pack and can take up to 150 tons to break it free. At this stage it's quite hard to convey the stress that I'm feeling. I can see how much work's involved in actually stripping it in preparation for me repairing it, not to mention the crane hire and the work in the quarry just to get it to our workshop. The downtime that the quarry is now under through loss of production, and this is all laying on my shoulders, being able to successfully repair this. My biggest fear being that I have misassessed the makeup of the metal, and it goes back to the quarry after weeks and weeks and weeks of work and cost and downtime. The biggest fear is that it simply breaks. So the stress on me at this stage I could do without at this stage in life. There's a lot on my shoulders. I'm up at night. I'm reading books. I'm researching online. I'm doing my damn best to ensure that this job is successful. Um, the time from start to finish, it was in the region of, I think it was almost 3 months when you add all the machinist's time, the post-weld heat treatment, the pre-weld shot blasting, the stripping of it, the craneage in the quarry. This is a colossal project. It's not the biggest item in the world, but for one person, it's a big project. Yeah, I lost sleep over this one. It's me versus it. It's my reputation. I'm trying my hardest. I'm entering into this in good faith. I'm freaking out. I'm not gonna lie. I'm freaking out. So I'm giving it my best shot, and that's all I can do. I go to bed at night and I know I've tried my hardest. So that's the pre-stripping done, ready to go into my corner, and at this stage I'm beginning to do more thorough weld investigation. So start with a little weld test, and then, as I say, a lot of research at night. I done a lot more testing on it that I didn't have on video. I hammered it, tested, done a blob of weld and literally hammered the life out of it to see how it reacted. Did it squash? Did it delaminate? Did it crack? Did it fracture? All these things, all these metallurgy style studies. I'm not a metallurgist. I have no degree. I didn't study this at university. My background's welding. I'm picking up how metal reacts as I go in life, and that's all I can do. So yeah, so we have it in my corner now, and the job continues. And stay with me, please. I put a lot of sweat and a lot of sleepless nights in this one, so I really appreciate your support, and hope you're enjoying it. So, before we go any further, brought it into my corner to do a highly scientific weld test. Add a small dab of sarcasm into that statement, but nonetheless, very easy, very quick, very simple, a great indicator of how this is actually going to react to being welded with mild steel plates onto cast steel body with mild steel wire. So simply get a piece of steel, simply weld it onto the cast steel, grind both of them so they're clean, no preheat, and hit it with the hammer and inspect the penetration and fusion, and see what the hold on, the yield force is like. Could be very scientific and make a particular length arm and put a particular force onto it and measure the force, but we'll have a very, very good indication just by hitting it. Doing this for 15-20 years, you really get a grip of what is taking exceptionally well and what isn't. So going to crack this with a sledge on the opposite side and open it out on its weak, open it up on its weak side and see where it breaks. It's moved about 10 degrees and it's still holding on nicely. So there we go. Very, very pleased with that. So what you see is The weld itself has yielded. So I'll take the phone out of the cover so we get a clearer look. This was just a quick dirty weld. Nothing fancy about it. You can see the large crystals at the bottom of the weld, partly due to no preheat and rapid cooling. The little pockets of impurities. So as you can see, I just hit this with a grinder and it still has little pockets of rust or oxidization, so the weld isn't going to be perfectly clean. But as I said, the main indicators we're looking at is to see how well the weld itself takes to the cast steel body of the crusher. There's absolutely no sign of it lifting off the cast steel whatsoever. That's the weld itself has yielded, so very pleased with that. I'll probably repeat it a few times, and I may actually look into some different wires as well, better suited for mild steel, cast steel. We would use 309 stainless, which would probably be better suited, probably slightly higher strength joints also, but I just need to check to see if it's suitable for extremely high cycle fatigue loads and stresses. But I think either mild steel should be suitable, but I'll speak to some of the metallurgy guys, the professionals, and get their advice, and we'll come to conclusion on the best wire to use. But that's very, very promising to start with. So fast forwards another week, the parts have just arrived back from the shot blasters. Everything's nice and clean. I've brought a big table in and I'm going to set it up to assess the joint. Even this takes an absolute age because everything is so heavy. Everything about this jaw is pretty brutal. This half is about 5.5, 6 ton. That half something similar. And this right here is the issue. Nice cast steel, and if you look closely you can see where some poor bugger has been in with the welder before, just to make it interesting for me. So in this half we're working up against a bulkhead, and this half we have webs. So I'm going to stand and look and assess and scratch my head some more and walk around it and sit and hold my chin and walk around it some more and try and come up with a game plan. I'm not going to lie, it's hard not to get intimidated at the very start of a job like this. But I've done it before and I'll do it again. In fact, it's probably about the 5th one I've done. Although I reckon this would be joint biggest I've done before. So the first problem that comes to mind is the face that I would have used on all of the rest was all perfectly flat, making it very simple to set it on a level base. Unfortunately, this isn't the case with this one. I'm going to have to use spacers and packers to block it all onto one level. Just a bit more fiddly and time consuming, but we'll get there. This is the side where you can see someone else was here before me. So needless to say, the first part of the job will be prepping all of these webs in readiness for a full penetration weld. We have to remove any compromised sections like this. You see the fracture line, so I have to remove all of that. When I have it all fully prepped, I'll probably do a dye test just to ensure that I've removed all compromised material. So you might ask, what is the point of setting it up like this, not welding it? Offering it up to inspect which direction the break has actually occurred is quite important, because it affects how I'm going to prepare the joint. If it's broke at this angle or broke at that angle, will dictate whether the prep may be on the inside or the outside, on one half or the other half. So down there you can see a large lump broke out and a piece of compromised material left. Based on that, I'm probably going to put the prep in that direction. So yeah, currently doing some tests, file tests, trying to determine what the material makeup is in order to choose the right filler wire for welding it back together. So I have filed a little bit of the material and compared it to some mild steel welding. The mild steel welding files a little bit softer than the base material. Based on that, I would guess that the base material is of a low to medium carbon cast steel. So we're actually waiting at the moment for a spectrum analyzer gun, which should give us a breakdown of the metals in the cast steel. So once we have that information, we'll be able to make a better informed choice. So the file on this, it doesn't bite or drag very hard. It's quite shiny and skiddy, which means it's hard. When I file some mild steel welding, It's a lot grabbier and slow and gritty, which means it's softer and the file is cutting it easier. So this is not just as hard as the base material itself. So many thanks to our good customer John of Clearways, a long working relationship with them. He very kindly came up and loaned us his spectrum analyzer, which was able to analyze the cast steel and tell us the percentage of metals in it, being manganese and silicon and molybdenum and nickel and things like that. And you could see the actual percentages, which let us know what filler material to use. This is a very expensive tool in the region of £30,000. We can't justify spending that to be used perhaps once a year. So in the meantime, while I'm researching the welding procedure, I still haven't decided how I'm going to go about it. We'll start the weld preparation process. So we'll separate the two halves, get the gouger fired up, and start to remove all of that compromised material. So this is very interesting, and I've came across this many times. This is a large flaw in the original casting. It appears to be either an air bubble pocket, or very often I come across a large pocket of sand which has been trapped within the original mold, because these molds are made with sand. I'll gouge out this cavity and fill it up with weld in the repair process. It's no big deal. So this is a difficult part, is deciding which way to prepare these very badly broken pieces. So normally I would want this to have a 45 into a point, but all of the material is broken to one side, so this section is going to be prepped to one side. If I do a 45 and a 45, it's going to leave me with a 20mm gap, which I don't want. So this is close to the point of contact on the original piece, so we'll have to do a 45 all to one side here. Then up here you have broken at that angle here again. It's going to change over from a prep angle this way to a prep angle that way. So yeah, I just have to be very careful not gouge the wrong side, leave myself with a gap. Here's another problem child here. This lump needs to be removed, crack followed, compromised material removed. We just have to see where that goes to. There's places I may end up with a gap, and I'll just have to pad weld it until the gap is closed. No choice. You can see the section where someone welded it on site. It's easy to criticize somebody's welds on site. I don't know who welded this, but you never know what conditions they welded in. They could have had the worst welding machine in the world. They could have been stuck in the worst position. You don't know how much space or access they had to get to it, so I'll never criticize somebody's welds. They're out there giving it a shot, trying to make it work. Unfortunately, this time it didn't. So yeah, we'll clean this face up I finished cleaning that one up. I take it a stage at a time, moving between the two, because they have to correlate to each other. 2 days of gouging, prepping, cleaning, and all the grinding work starts soon. It's Friday, Easter Friday, Good Friday, and it's home time, and we've got a long weekend ahead. So I am going to go to Scotland on a tractor road run now and relax for a few days and chill out. I'll be doing a video of that also for the tractor fans. Check it out, it'll be sometime after this video. So yeah, happy Easter guys, have a good one. I'll catch you when I come back. Cheers. that's the entire surface of the broken joint ground back, and during the grinding back, that's when I get to really closely inspect every square millimeter of the surface for any cracks that I may have missed the first time. So there was a couple that I just wanted to chase up, follow through a bit further. I've done that, and it's now entirely crack defect free to this point. So I'm actually going to set it up a completely different way than I've done the last one, and do a test fit. I'm expecting a few gaps because unfortunately some of the material was too compromised. It had to be removed. Therefore it's going to leave me with a little gap to fill. So I'm just going to pad weld those up in a block, and that'll require a couple of test fits, just to assess the size of the gap and to ensure that I can grind it back to a proper fit, that all the joining edges all meet with the same distance, nice and square. So we'll get her on the time lapse, we'll get the crane over and start some heavy lifting. So there we have it, guys. That was basically the entire preparation of the joint before welding, and we're now 51 minutes into the video, and I'm gonna have to call it wrap at this stage. Most of you will be falling asleep. Thanks to anybody that's still watching at this point, and if you enjoyed it, I'd love a thumbs up, and even better, if you want to see more, click that subscribe button. So stay tuned. The second part of this video is coming very soon with the massive welding procedure and heat treatment and then machining, the rebuild, and hopefully a site visit to see it working. So stay tuned for that, guys. Thanks for the support. See you on the next one.